Colloids. Colloids basically are one of the most important topics in the surface chemistry. From the junior level, we have been knowing that the mixtures are of three types. The first is when we find that the mixture of the two substances is completely homogeneous in nature. So when mixture is homogeneous, we call it true solution. But when the mixture is appearing to be homogeneous, but actually it is heterogeneous, it's called colloid. And when the mixture is heterogeneous even in the appearance, it's called suspension. Here we will be studying colloids. So colloid is basically a heterogeneous system of two components. Since we have in a syllabus binary system, we'll be only talking about two components. So remember, colloid is a heterogeneous system of two components in which one component remains suspended, remains dispersed in another substance, which is basically called the medium. So the substance which remains dispersed is called dispersion phase, and the medium in which it is present is called dispersion medium. So that is how it has two components. So what is exactly a colloid? Remember, a colloid is a heterogeneous system of a finely divided particles or substances which are called dispersion phase. We call them dispersion phase because they remains dispersed in a medium of another substance which is called dispersion medium. So this is how it has two components. Now, these colloidal systems or the colloids are very important and very widely used in our day-to-day life. From our toothpaste to hair gels to shaving creams to even the jams and the jellies, whatever we eat, to milk and all other examples, paints, etc. We find that we have numerous examples of colloidal systems or colloids present around us. So what is important to know is that let us first understand their classification, and then we will move on to their preparation, purification, properties, and etc. So let us do first their classification. See, before moving into the classification of colloids, let us first give a thought about the major differences between a normal solution and a colloid. See, in normal solution we have particles maybe which are either the ions or the small molecules which gets easily mixed up in the medium which is called solvent, and their size is very small. Whereas what we find in case of colloid is that the particles which gets dispersed are of very large size. They are called macromolecules, and this is in comparison to the particle size we have in case of a true solution, and they remains dispersed in the medium which is called dispersion medium. So they never settles down, they always are in the dispersed state, and that is why they are called dispersion phase. Now the major difference between the true solution and the colloid is basically in their particle size. The size of the colloidal particles is from 10 to the power minus 6 to 10 to the power minus 9 meters. If the particle size is smaller than this, then that definitely it belongs to a true solution range, and if it is larger than this, then it is for the suspension. But we have, yes, colloidals of this range. So this range is for colloids. Now this range, if we consider the particle of this range, we find that they are large enough than the true solution particles. That is why they have, since they remain dispersed in the medium, they have very large surface areas. And due to these large surface area, they show certain very peculiar different properties which are their characteristic features, which we can't find in any of the true solutions or suspensions. And due to these characteristic peculiar properties, we are studying them in this chapter called surface chemistry. So now let us, I can give you an idea of something like these colloidal are the substances which can can easily pass through a normal filter paper because their size is very small in comparison to the pores of the filter paper. But yes, the colloidals cannot pass through a normal animal membrane or a plasma membrane. Another certain things like they never settles down. They are always in the dispersed state, but they appears to be settling down like a true solution, like mixed up in a normal mixed up in the medium like a true solution. So there are very certain peculiar properties which we find associated with these colloidals.